This is packet number 13, problem number 6, and we're looking at a mouse going up and down the x-axis. So the mouse is moving to the right up until t equals 4, and then it is moving to the left from 5 to 8. We are asked to create a position curve first, so position versus time. And what we need to think about is that at t equals 0, the mouse is already away from the origin. So there is a distance between the origin to where it's starting. To show that on our position curve, we need to just have the mouse start above the origin. Now, as the mouse moves to the right, up until the first 4 seconds, that means its distance is getting farther and farther away from the origin on our original graph and higher on our position graph. Now we need to think about the fact that the distance between 0 and 1 is farther than the distance between 1 and 2. Likewise, the distance between 2 and 3 is smaller than 1 and 2, and the distance between 3 and 4 is smaller than the distance between 2 and 3. What that means is this little mouse is slowing down as it walks along the x-axis up until 4. Because if it's running, it gets farther between 0 and 1 than it does between 1 and 2. It can't be going as fast as it did in the first second. So the way we show that on the curve is a function of steepness. So at first it's going steeper, the slope is steeper, but it's going at a decreasing rate up until 4. So it started away from the x-axis, it increased its distance from the origin up until 4. Now the little guy has started to move back towards the origin, and in fact past the origin. Now take a note also that at t equals 5, its distance is just about at the same point as it is at t equals 3. So that's the distance from the axis. Likewise, at t equals 6 it is equal to t equals 1, and at t equals 7 it's at the same position. So how do we show that? Well, if this is at t equals 1, then at 7 it has to be at the same height. If we say that this is t equals 1 and it's this high, then at t equals 6 it should be at the same height. And then at t equals 5, it's going to be at the same height as it is at 3. So give or take those. And then we're going to come down. And the last thing to take note of is the little mouse is now past the origin on our original graph. That means it has come down and gone through we show that on the position graph as being on below the x-axis. So that happens somewhere between 7 and 8. Other things you ought to notice is that at 4, it is the farthest to the right up on the original curve. So since it's farthest to the right, it should be at the highest point on the position curve. The next problem, part of the problem takes us and asks us to draw a velocity versus time curve. So we can figure out our velocity from our position curve that we just created. Since our position graph is the steepest it can be right at the very first part, because it's concave down, the velocity is steepest at the very beginning, and we're at a max at t equals 4. When we're at a max, that means the velocity is 0, so I know we have to go through 0 on our time axis at t equals 4. If at the beginning we're at our highest velocity, well, I can start it anywhere I like, but I need to make it as high as I can, and then my slope is decreasing to 0. And after 4, these are negative slopes on the right-hand side of 4. So if they're negative slopes, then I show that on my velocity curve by being below the x-axis.